A crater so violent it erased millions of years of rock in seconds. A river the color of rust, flowing through a landscape that shouldn't support life, and somehow does. A desert so dry that scientists once called it the closest place on Earth to having no life at all. A canyon of dry ice, fog and frozen bone, sitting under the coldest sky on the planet. These aren't photographs beamed back from another world. They are places on Earth. And some of them are so convincing that space agencies use them to prepare for a planet 140 million miles away. Mars didn't start out red and dead. Billions of years ago, it had rivers. It had a thicker atmosphere. Then it lost its magnetic field, its air thinned, and the surface froze into the rusted, cratered world we see today. Earth almost went a different way, but in a handful of places, geology, chemistry, and time conspired to build something that looks like it belongs on the other planet entirely. Not similar. Not Mars-like. In some of these places, NASA scientists have stood on the ground and genuinely forgotten, for a moment, which planet they were on. 7 of them. Each stranger than the last. Location 1, Haughton Impact Crater. No trees. No rivers cutting through soil. Just a flat, shattered basin ringed by fractured rock, stretching toward a horizon with nothing on it. The silence here isn't peaceful. It's total. This is Devon Island, in Canada's high Arctic, the largest uninhabited island on Earth. At its center sits Haughton Crater, carved by an asteroid roughly 39 million years ago. The impact vaporized rock instantly, fracturing the bedrock for kilometers, and leaving behind a bowl of shattered stone called breccia. Because the Arctic climate here is cold and dry, erosion has barely touched the crater since. What should have softened over millions of years instead sits nearly frozen in time, a fresh wound on an ancient landscape. Since the late 1990s, NASA and the SETI Institute have run the Haughton Mars project here, testing rovers, spacesuits, and drilling equipment in conditions that mimic the Martian surface. Cold, dry, radiation exposed, and eerily similar in mineral composition to craters photographed on Mars itself. Some of the impact rock at Haughton contains minerals nearly identical to those found by the Curiosity rover in Gale Crater, meaning scientists studying Mars data can walk over to a shelf and hold the Martian equivalent in their hand, mined thousands of kilometers north of the Arctic Circle. But Earth wasn't finished surprising us. Location 2, Rio Tinto. A river the color of dried blood, cutting through orange and violet hills. No fish move in it. No birds land on its banks. In southwestern Spain, the Rio Tinto, the Red River, has run this color for thousands of years, long before modern mining ever touched it. Ancient civilizations believed the ground itself was cursed. Beneath the region lies one of the largest sulfide ore deposits on Earth. Bacteria feeding on iron and sulfur compounds in the rock trigger a chemical reaction that leaches iron into the water, turning it acidic, with a pH sometimes closer to battery acid than river water, and staining it a deep, rusted red. That extreme acidity should make the river sterile. Instead, microorganisms thrive in it, surviving on chemistry alone rather than sunlight. NASA and the Centro de Astrobiologia have studied these extremophiles for years, because if life can survive here, in water saturated with iron and acid, it raises a real possibility for the ancient, iron-rich water that once flowed on Mars. The reddish, iron oxide-rich minerals lining the riverbed are strikingly close in composition to the rocks and dust that give Mars its color, meaning this river isn't just red like Mars. Chemically, it's built from some of the same ingredients. If you thought that looked alien, the next place removes almost everything red and replaces it with something worse, nothing at all. Location 3, the Yungay region, Atacama Desert. Ground the color of ash. No visible insects. No visible plants. Some patches of soil here haven't felt rain in recorded history. High in northern Chile, the Yungay region of the Atacama Desert sits in a rain shadow so severe that certain areas may not have seen measurable rainfall for decades at a time. Two mountain ranges, the Andes and the Chilean coastal range, trap moisture on both sides, starving the valley in between. Add intense solar radiation and mineral-rich, oxidizing soil, and you get ground so hostile that for years, researchers found almost no detectable microbial life in certain soil samples, a result almost never seen anywhere else on Earth's surface. NASA has used Yungay as a testing ground for life detection instruments built for Mars missions, including instruments related to the Viking landers and later rover technology. If a device can find life, or correctly detect its absence, in Atacama's most punishing soil, scientists gain confidence it could do the same on another planet entirely. Despite conditions once compared to the Martian surface, some microorganisms here have been found surviving inside porous rocks and salt crusts, pulling moisture from fog and humidity too subtle for human senses to notice, proof that even in Earth's harshest desert, life still finds a crack to hide in. There is one place where the ground doesn't just look strange. It looks like it was carved by something with no interest in being understood. Location 4, Makhtesh, Ramon. A massive crescent-shaped crater, over 40 kilometers long, its striped walls layered in red, purple, and white rock, as if the desert had been sliced open to show its insides. Makhtesh, Ramon sits in Israel's Negev desert. Unlike Haughton, this crater has nothing to do with an asteroid at all. It's a geological formation almost unique to this corner of the world. Millions of years ago, this region lay beneath an ancient sea. As tectonic uplift raised the land and erosion cut through the softer rock beneath the harder cap layers, it hollowed out a massive elongated basin. The exposed strata reveal hundreds of millions of years of sediment, volcanic rock, and fossilized seabed, each layer a different mineral, a different color, a different chapter of Earth's past. Geologists come here to study rock layering and erosion processes that mirror the kind of stratified terrain photographed by Mars orbiters, landscapes shaped by long-vanished water, and wind acting on exposed rock over immense timescales. Somewhere within those layered walls lie fragments of some of the oldest volcanic rock in the region, meaning a 5-minute walk across the crater floor can take you across geological time spanning hundreds of millions of years, layer by layer, like flipping through pages of Earth's own diary. But Earth wasn't finished. The next place doesn't just resemble Mars from a distance. It fooled photographers into thinking their pictures had been mislabeled. Location 5, Biosphere de Enays in Wilderness. Stone shaped into balancing spires, dark caps perched on thin necks of rock, hoodoos scattered like abandoned chess pieces across a badland with no roads and no signs. Tucked into a remote stretch of New Mexico, the Biosphere de Enays in Wilderness has no marked trails. Visitors navigate by landmarks and instinct, walking through a landscape that seems designed rather than eroded. Millions of years ago, this was a swampy river delta, not a desert. Layers of sandstone, shale, mudstone, and coal were laid down by shifting rivers and vegetation, each with different hardness and resistance to erosion. As wind and rain wore the softer material away, the harder caprock layers protected the stone beneath them, leaving thin, top-heavy spires standing where the surrounding earth has vanished. Researchers studying wind erosion and rock formation patterns in places like this help build models for how similar hoodoo and butte formations may have developed on Mars, where orbital imagery has revealed comparable eroded spires shaped by ancient wind and potentially water. Fossilized wood, petrified logs, and dinosaur remains have been found scattered through this badland, meaning a landscape that looks like it belongs on a lifeless planet was once a lush, humid wetland teeming with life. There is one place left. And it isn't just Mars-like. It's the place NASA sends astronauts before they ever leave Earth's atmosphere. Location 6, McMurdo Dry Valleys. No snow. No ice sheet. In the coldest, windiest desert on the planet, some valley floors haven't seen precipitation in millions of years. This is Antarctica, but not the Antarctica of postcards. The McMurdo Dry Valleys are a set of ice-free valleys where katabatic winds, rushing down from the polar plateau, evaporate snow and ice before it can accumulate, leaving bare rock and gravel exposed in one of the only truly ice-free regions on the continent. The extreme cold, near-total absence of moisture, and intense UV exposure combine to create a polar desert more arid than most of the Sahara. Frozen lakes here can be covered in meters of ice year-round while still holding liquid water beneath, kept from freezing solid by pressure and salinity, a phenomenon scientists believe may explain subsurface water on Mars today. NASA has used the dry valleys since the 1970s as one of the closest terrestrial analogues to the Martian surface, testing life detection instruments and studying the extremophile microbes that survive here, some living inside porous rock, others inside permanently ice-covered lakes, as models for how life might persist, hidden beneath the Martian surface. Some of these lakes have remained sealed under ice for thousands of years, creating isolated ecosystems that have evolved with almost no contact with the outside world, self-contained biospheres frozen in place, not unlike what astrobiologists hope to one day find beneath the ice of Mars' polar caps. Location 7, Wadi Rum. Towering sandstone cliffs rise from a valley floor of fine red sand. The silence stretches for miles. No vegetation breaks the color. No water moves anywhere in sight. In southern Jordan, Wadi Rum has been shaped by wind and water erosion into a valley of monumental red cliffs and wind-carved rock formations. Its sand tinted deep orange-red by iron oxide. The same iron-rich minerals that stain the sand here are chemically related to the iron oxides that give Mars its distinctive color. Millions of years of wind erosion, combined with rare, sudden flash floods, sculpted the massive rock walls and arches that define the valley today, geological processes strikingly similar to features seen in orbital images of the Martian surface. The visual and geological resemblance is so strong that Wadi Rum has been used as a filming location to depict Mars itself. But beyond the cameras, its landscape has genuinely helped scientists visualize how wind-driven erosion sculpts iron-rich terrain, the same forces believed to have shaped Martian dunes and canyons over billions of years. Ancient rock inscriptions found throughout Wadi Rum, left by cultures who passed through this valley thousands of years ago, prove that humans have walked across Mars' red sand for millennia, long before anyone knew there was another planet that looked just like it. Seven places. 7 different stories. A crater without an asteroid. A river built from acid and bacteria. A desert almost too dry to hold life. A crater sliced open like a geological book. A wilderness of stone sculptures grown from an ancient swamp. A polar desert colder and drier than anywhere else on the planet. A red valley carved by wind and flood. None of these places are trying to look like Mars. They simply followed the same physics, the same chemistry, the same slow patience of time, and arrived somewhere eerily familiar. Maybe Mars isn't some alien anomaly at all. Maybe it's just Earth's cousin, a planet that went through the same processes, the same eras of water and wind and volcanic fire, but never got the chance to keep going. The greatest alien world we've ever discovered may have been beneath our feet all along.